All right, great. So this is your interview with interviewing.io, and um, I'll go through like a simple DSA algorithms question. Just logistics on the interview. We'll probably spend the first 5 minutes doing intros. I have two questions that I want to ask you. We'll see how you get on with the first one, and if you have time, we can go into the second one as well. Um, and we'll try to leave some time at the end for feedback and any questions you have. I'll also provide you with written feedback after this interview. Does that
Okay.
all sound good?
Yeah, that sounds great.
All right. Great. So I can sort of briefly introduce myself. I'm Anshul. I work as a staff ML engineer for ShareChat in the UK. And before this, I was at Meta again as a ML engineer, working on ads ranking. And before that, I was based out of India, working as a uh, data scientist, and as a software engineer in different startups. Um, yeah, maybe you can briefly introduce yourself.
Yeah, I worked at Google as an entry-level software engineer for almost 3 years. Recently got laid off. Um, Prior to that, got a PhD in essentially medical imaging, bioengineering, and nuclear physics was the background. And so decided I didn't want to do academia. Found an opening at Google and was able to switch there. Now hoping to stay in software, maybe in the long run switch into ML to utilize my PhD better. But for now, software engineering.
Yeah, sounds great. And can you share like what kind of interviews you're targeting, like Meta or Google?
Well, right now I don't think Meta's doing E4, so I'm targeting right now Amazon.
Okay.
Um, and then I have a phone screen with Quora and Reddit coming up.
Right. Great. So I'm not too familiar with specifics of these companies. The coding interview that I'm gonna do today for you is gonna be more in meta style, and I
Okay.
can talk a bit about like my experience with different companies, like how they typically interview. But just sort of keep that in mind a bit. So every company has their own nuances, right? All right. Anyway, we can now get started with the question if you're ready.
Sure. Yeah, let's do it.
Okay, great. Okay, so this question is going to be really simple to communicate. It's basically like you're given a graph and you have to clone it. So I'll just paste the description here. Yeah, so you're given a graph. The tricky part is it's sort of implemented as a custom class, um, kind of a typical implementation of a graph. So you have a node, each node has a value, and it also has a list of neighbors, which is again a reference to other nodes, right? So this node is connected and undirected, like the graph is connected and undirected, and you have to return a function that takes the graph and returns a deep copy of the graph.
Okay.
Over to you.
Okay. So it's an undirected graph. And I start with I'm just given a node to start with.
Yes, you're given a node in the graph.
Okay. I mean, my first thought is I could just do DFS, um, but use a seen or visited set to keep track of the nodes I've seen already, so I don't revisit nodes and reduplicate them. Um,
Okay.
um, so that should end up with me visiting each node once, so like on time. Um, yeah,
Right.
I think that would be it. I don't think there's any other complexity with that.
All right. And what will you do in the BFS?
So essentially, I'd visit a node, like the starting node, um, and then I would append to the neighbors list. Well, sorry, I'll visit a node, make a copy of that node by creating a new node, and then to that node's neighbor list, I would append each of the neighbors the of the original node, a copy of the neighbors of each of the original nodes. So the appending function will append the DFS of each neighbor, if that makes sense. So maybe I should type this out. So go through with start node, um, create copy with val um, for each neighbor, copy.neighbor and DFS neighbor. And then before I even start this, I might also add scene here too in the loop before I do the copying. Just set add neighbor set. So something like that.
So you're doing depth first search, is it?
Yeah. I mean, I could also do BFS. In some ways, BFS also makes it kind of clean too. Um, we could do that as well.
So here, what is DFS neighbor?
Oh, so because I'm creating the copy, I would, for each of the neighbors in the original node, I'd run the DFS to make the copy of the node and return the copied node.
Okay. Uh, so can you just walk through how it would work with, let's say, just a simple example. Let's say we have just 3 nodes and it's like a linked list, right?
Okay.
How would this work?
So I would,
It says node 1, node connected to node 2, node 2 connected to node 3. Yeah,
so
simple.
like something like this, let's say.
Yeah, yeah.
So I would copy node 1, and then just make a copied node, and then copy, so copy
Let's call
value.
it like 1 prime or something, right? So the
Okay,
copy
and
of
then
1.
one prime dot neighbors are going to equal DFS for each neighbor, DFS neighbor. And then before this, before this, I would also add like a um, scene neighbor to make sure I don't copy the neighbor again. Um, so in the example, that means I would run, since there's only one neighbor in this case, it would be, I would create one, and then, and then I would create 2, and then create 3, and then it would return 3 prime as a neighbor for 2 prime, and then my final result would return 1 prime. Does that make sense?
Okay, and what if the graph has a cycle? Maybe we can just say that there's a connection from 3 to 1.
Right. So if there's a cycle, it shouldn't repeat because of, I'll also do a check for the, um, so the code would be like, um, uh, if neighbor not in scene. So I wouldn't run DFS unless it's in my scene set.
Okay, go ahead and implement this.
Do copy node, node. Um, we could do set here. Next thing is make the node. So we'll do new node equals this node dot val. What was it? Neighbor? I think that's right. Neighbors. Scene dot ah instead of instead of uh
Mm-hmm.
instead of a set, I should do a hash map.
Right. And why is that?
Because I need to return because there's cycles, I need to return the
Yep.
yeah.
Yep. Yeah. You don't just need to check that it's visited. You also need the node so that you can
Yeah.
update. Right. Yeah. 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 And
Scene
a
dot
cycle that you want.
neighbor equals DFS neighbor. And then we could just do new node dot neighbor dot append scene neighbor. And then return. Oh, I called it helper. So for meta, I think you hand test it, right?
Yep.
So so let's try. We'll try the first case we have up here. So our first node would go through it. We create a new node with value 1, no neighbor yet. You would add this node to key in the hash map for node and neighbors if not in scene. Scene, we create this neighbor, helper, neighbor. So we run this again with 2. And then we'll run this again with 3. So that would be, so I have this new node 3. It has no neighbors. So 3 would have an empty neighbor list right now. And then it'll return 3. And then it'll return 2. And then return 1. So I think it works here, but there's no cycle right now. If there was a cycle for 3 with 1, it would just return seen in neighbor, which would be the new node. So I think that's fine as well. So I think this works.
Right. What's the time complexity and space complexity?
Time complexity would be O(n), because I'm visiting each node once, so n being the number of nodes. Space complexity would also be O(n), because I am keeping a scene hash map. And I'm assuming the new nodes as output shouldn't be considered.
It's a general graph. Are you really visiting each node once? If you're visiting each node once, do you need a hash map?
Sorry, what was that?
So why would you need a hash map if you're only visiting each node once?
I guess I'm visiting each neighbor once, but the hash map I thought is to be able to return the created node, to easily keep track of the created nodes for if there's cycles or things like that.
Okay, let me ask this in another way. For a generic graph with, let's say, maximum number of edges,
I see.
how
Yeah.
many
So,
times
so
would, yeah,
sorry to cut you off. So I think you're implying that it should be number of nodes plus number of edges, right?
yes.
Yeah.
Okay, can you just write that down?
Yeah.
Like the time and space complexity as a comment?
So we'll do V plus E for vertexes and edges for time complexity, um, and then O by N for space, and P are using a hash map. Excluding output. Or I guess this is V to be consistent.
Right. Yep. That sounds good. I'm just gonna type the next question here. So I'm not sure if you might have already seen this question. It's quite a common one, but yeah, still good practice. So let's say we are given two sparse vectors and we want to compute the dot product. So we have to implement a class called sparse vector where you give it the vector and it sort of initializes the object. And this class also has a dot product function where you can give it another sparse vector and it will compute the dot product between these two sparse vectors, right? And just for clarity, like a sparse vector is a vector that has mostly zero values. So the idea behind this question is you should find some representation to store the sparse vector efficiently, and that also allows you to compute the dot product efficiently.
Um, okay. So I guess how large are these sparse vectors? Why I ask is mostly like, what if I just keep the coordinate of each point? So it'd be 3, I guess, integers, the value, and then like RC for each point. But obviously, if it's this is
One
works with it.
dimensional, like they are like it's a one-dimensional thing, right? They're vectors, they're not
Oh
matrices.
yeah, sorry, it's a vector. You're right. So it would just be um, yeah. Then it would just be value by index, right?
Right.
If it's sparse enough, even though it's 2 points, if it's very sparse, then all you need to do is um, do like a hash map index equals val.
Right. And then how would you
And then the
compute
dot
the dot
product would
product?
just be um,
Okay.
for, you would just loop through the indexes in the hash map. It would be 0 if there's not a matching index on the other vector. And so you could just take either one of the hash maps, loop through the elements, and then multiply it by the corresponding index in the second vector.
Right. Um,
Should I write that
what's
out?
the what's the time complexity of this approach?
Um, Converting the vectors to a hash map would take O(n) time, with n being the number of elements for each vector. And then the dot product would be O(n) as well, assuming the vector is not actually sparse. That'll be like the minimum of the number of elements with values other than 0 in the vector,
All right.
between
And
v1
then
and v2. So for creating sparse vector O(n), we go through each element. Dot product will be, we could do min v1, v2.
yeah. What is the possible drawback of using a hash map?
The one that immediately comes to mind right now is just if it's less than 50% sparse, I'll be using more memory this way.
How will you use more memory? Okay, because your memory size is the number of keys, right?
Yeah, and
Is
so
that
if I'm essentially storing
no? It's really sparse. It's a really sparse vector, like hugely high
yeah,
dimensional and very sparse.
okay, yeah,
So that's
then
the problem.
if it's truly sparse, then that shouldn't be an issue.
The
The
space is not an issue, but um, what is the time complexity of a lookup in a hash map?
O of 1,
Um, is it really? How is that achieved?
how is that achieved?
Like, is it really always O of one in practice?
My understanding is yes, but maybe not.
Yeah, but like, okay, when you say maybe not, like, what do you know what can cause it to not be O of one sometimes?
I do not actually.
Are you aware of like how hash maps will be like sort of implemented?
Um, Essentially, there's a hash function.
Right?
That's that's pretty much all I know. The only thing I can think of is collisions, maybe.
Yeah, yeah. So what happens if there are collisions?
Um, then I actually don't know how hash maps resolve collisions, to be honest.
What would you do? Like, okay, so you put a hash function, right, on the value, and then you use that as the address to store the object. Now, uh, the hash function sort of guarantees, like with a bunch of keys, that all the indexes will be unique, right? But let's say you have a collision. Now, there's already a value there. What's the easiest thing you can do?
Um, you could make that bucket contain multiple, or change your
Yep.
hash function.
No, I mean
Mhm.
every hash function will have some collisions. right? Of course, you can choose a really good hash function, but let's say keeping the choice of the hash function constant for a while, we're using the best possible hash function. But yeah, like you said, there's a collision, so we add in another object there, right? And
Yeah.
if by some dumb luck we have like lots of collisions, then those buckets will contain lots of values, and then your lookups won't be O1, they'll be like ON in the worst case, right?
Okay. I guess we could
So
also
can
use
you,
a,
yeah,
sorry,
yeah, just
um,
continue your thought. What can we use instead of a hash map,
maybe just a straight list with a
right?
um, with a index value pairs.
Okay.
Um, and
Maybe
then
write an example here of how that list would be. Let's say we had like this kind of vector, bunch of zeros and one. Yeah. So how would this be represented?
so then this would be um, O one. So this is 0, 1, 2, 3, 4, 5. So we'll do 5, 1. Then that'd be it.
Right? And then how would you do the dot product computation?
So let's assume we have a second matrix. Hmm. So one, um, I'll do like 7, 1. Um, my first thought is you could start with the first matrix and then just do binary search for the index in the second matrix.
Okay, what is the time complexity of that?
Then you would get n log, well, not n log n, you would get log n for each search times each um,
Like n log n,
element
right?
in your list.
So like if you say n is the size of the reduced list, it's n log n, right?
Yeah.
Yeah. So can you reduce that?
Um, technically, these things will both, I guess we could change it to like min uh, n1, n2, where n1 and n2 are the lengths of the two. If you do a pointer in each, you check the value. Like 0, you would iterate through this matrix until you hit 0 or past 0 or hit the end. Um, so like here I'm looking for 0, I find 0 right away. So these match, and then I go here at 5. Um, I could just resume where I was before because I know 0 was the last element. If this 0 isn't here, the last element this would stop on would be 7. So I could iterate so that I can go through each of the matrices in n1, n2 time.
Yep. Okay, can you implement that?
Yeah. Um, so first I think I'll just do class sparse. That's lowercase c. Yeah. Sparse vector. Or I guess it's already a vector, right? Sparse vector is already a class.
Yeah, maybe you can implement the constructor or something with
So like
constructor take like num. I've copied the Java example. Sorry for that. You can just translate it into Python. So
well, you
constructor
did.
can take nums. Yeah.
Oh, I see. So then we take nums here,
Yeah.
and then self that. I'll just call it compressed equals list I comma num for I num in enumerate nums. I think that's all I need. If there's nothing called self.compress, I then I do total equals if v2.com press j is greater than compress I. Shoot, all these need zeros. 0, 1, 1, 0, 0. Okay, so if v2 is greater than that, then we just increase this. Else j plus equals 1 total. I think that's all there is. So if less than this value, we'll keep incrementing j. And then if it's v2 is greater than self.compress, we increment I. I think that works. At least conceptually, I'd like to test it though. So we could do v1 equals sparse vector. We'll do Oh, we're supposed to hand test it, right? Okay, let me hand test it then. Um, so this would come down to 0, 1, 5, 1.
How would you get that zero, the this representation from your function? Can you just walk through the statement that you've written?
You're saying, so this is my starting vector,
Right? And then
and
what's
then this
the list
comes
compare?
from the initialization of this.
Yeah, can you just walk through that?
Walk through this.
Yep.
Yeah. Oh, if um, there we go.
Yeah, now it would give that. All right. Yeah, I think this works. What's the time and space complexity? I've already mentioned it's N1, N2. All right. Now we have some time. I think at this stage it would be a pass for the meta interview. Um, but we have some time. If you want, we can do another follow up. That's up to you, or we can discuss the feedback.
Um, what do you think is more valuable? I guess for me, where I feel weak is communication, probably.
I think we can do one more follow up. Typically, you would not get this since you've already done like two questions in 45 minutes, which is like really good. Uh, but let's do a follow up. All right, now the same problem, but now you're dealing with like 2D matrices.
I see. Um, so I think this is how I was approaching it before, maybe. Um, so we can compress it the same way, but it might not be as straightforward in terms of the dot product now. Huh. So let me see. If we do, our data structure is now our row column value. Although I'll definitely compress it, it becomes how do we multiply it efficiently. Um, I mean, I think we could do the same concept. We would first try to match the row. Um, if the rows, if we, so if we have V1 and has something like 1 comma 1 comma 1, 2 comma 1, and then V2 would be 0 comma 1 comma 1, and then let's say we have 2 comma 2 comma 3. I think we would first search for matching rows using similar algorithm as above, and then search for matching column. Um, Other optimizations we could do, if we don't collisions hash map rows. So I don't know how large these matrices, but if it's really large, we might have to go the first step based on our earlier discussion. If we don't think our collision
I mean,
likelihood is
the
high.
same, nothing changes in 2D, right? It's the same trade-offs and everything, right?
Yeah, then in that case, then I think it would be I could do like a row by column kind of base search method. Um, so first
Okay,
using
I
the
think
same.
uh, maybe you should think about like, okay, how does matrix multiplication actually work?
Uh, dot products are different.
Right. Maybe
um,
you can just take an example matrix and just think about like how does the multiplication actually work?
yeah. Okay, so maybe I'll use a dot string. So we have like a 0, 1, 2, 3, 2, and then for dot product, it's a row by column. Uh, so that means first we have to check if our rows match the column. So it'd be a multiplying with this one, it'd be like a 2 by 3 matrix. So it'd be like, so something like that. Um, and then you perform vector multiplication between this row and this column.
Right.
So
So
because it's
can
vector
you,
multiplication, we can reuse this dot products concept
right,
as long as we store
exactly.
it properly.
Right. Right. It's just that you'll need to create like the sparse vector representations properly, and then you can just reuse them, right?
Yes. So I have,
Yeah. I mean, it's up to you whether you want to implement this. In case you're feeling tired, like it's okay. This is just a extended follow-up, I think.
yeah.
You
I mean,
got the
it's
concept,
an
right?
interesting problem. I like the problem. I don't know
Yeah.
if I'll want to be able to code it in time and get feedback or not, but yeah. So I think,
Yeah, all right. Yeah, we can proceed. Like, I think, it's just that you just need to sort of transpose the second matrix, right? Convert the rows into columns. That's it. And then you can just reuse the above implementation. That's it, right? So usually, like if you get the second question for meta, um, if you do really well on the first thing that you did, and implement it really quickly, they'll give you this follow-up. And then, you don't have to completely implement it. Usually, they'll ask you like two questions in 45 minutes with the implementation and time complexity. And, the questions are fairly standard. So like these two are pretty good examples of questions. I think the first one, the main trick was tell Isaac that you need to use a hash map, right?
yes,
And I usually, when I used to interview, I used to give both of these questions together because in the first one, the trick is actually using a hash map, and in the second one, the trick is actually not using a hash map. uh, because, like, the reason is a bit subtle, but it's related to collisions, also related to like, hash maps are actually difficult to implement, um, in practice because like you need dynamic memory allocation and stuff, right?
Right.
um, or you have to take like a modulo on the hash function which increases the collisions. So why have all that complexity when you can just go with the simple approach which you can implement with like contiguous memory? If you wanted to
Right.
do like a really low level implementation, right, you could just have like an array, right, and could be like, could even be like a linked list, right? It doesn't have to be a dynamic array, right? So
Hmm.
like if you were to do a really low level implementation on any device, it would work very well. And that's why this implementation is better than the hash map. And then 2D case is more about like just, like can you translate the maths into like actual code and then handle all the edge cases properly. Even though there are not many edge cases, so it's not like really complex coding wise either. Yeah, so I think you did pretty well on both these questions. It would definitely be a pass on my end. The only thing I would say is, just when you're doing the dry run, I noticed that, you were sighing a bit before doing that. I can understand it that, it's kind of irritating to have to do that, but, you know, uh, it's always better if you find a bug yourself. Like, I think I didn't have to prompt you a lot to find the bug in the second implementation, but yeah, just be sort of mindful about that a bit, right? I understand that, it's sometimes a bit frustrating to have to do that, but, for the interviews, you have to kind of, you know, be in the right zone, you know,
Yeah.
like be prepared to do whatever it takes. That's mostly what, like, that's part of what they're testing with these interviews. Like, do you actually want to work there? Will you actually put in the work to, like show sort of your best side in a way? So, I mean, it's a minor nit. It's definitely not something that would count as any negative feedback to you in the interviewer's feedback. They would definitely pass you, and you can miss things, but it's always better. Like once you write a code, sometimes you do miss small things like that, and if you do like a really thorough dry run, it's very easy to find those bugs,
Yes. Yeah.
right?
I think for
If
me,
there's another bug on, let's say, line 100 where your I is less than length, but J some goes up to the length for some reason.
oh yeah, also,
Yeah, I mean these kind of typos happen, right? And if you do a really, I mean they're not deal breakers, but if you like it depends on the question. So for this question, there are not many edge cases, right? So no one cares. But if there are edge cases, and if the interview is evaluating on your ability to actually figure out those edge cases, and then you miss one in the implementation or something, right? Uh,
mhm.
then it could be a problem. But um, usually interviewers will, bug you at least a couple of times to try to find it, right? Like if you have a bug in your code which they have spotted and you have not spotted, they'll ask you to try run again or try run it with another edge case, right?
Yeah.
But then sometimes, you might not realize it if you don't try run properly, right? And
Hmm.
yeah, so it's always better. Like, I mean, you are pretty well prepared. The first question you implemented was without any bugs. Even the second one, like you realized the two pointer approach pretty fast. Implementation was also pretty good, right? Like it's pretty neat and everything. So, like, just be slightly more careful and you won't commit any, like, just understand that whenever you're doing interviews in a stressful situation, you will make mistakes, right? So when you're actually checking it, be very very careful and be very thorough, and that way you'll avoid these mistakes. And also, that's one of the things we look for as interviewers, is that how well do you test things, right? And if you're able to actually find a bug while testing, that's seen as a positive yourself, right? Without the interviewer having to prompt. So, like, just once you're done with the implementation, dry run it on your own. right? Don't wait for them to prompt you. Like take charge of the interview. Say, okay, I'm done with the implementation. I'll dry run it now, and only say you're done when you've done the dry run and you're absolutely sure that everything is correct. Then say that okay, this should work, right?
Okay.
That's just like a minor point. Okay, anything else you wanna ask me about?
So some of the stuff I found I've struggled with, it might not apply to meta because I feel like the meta questions are pretty well sparse,
Right.
but like for some companies, or well parsed, I should say, but some companies I find like the questions are very ambiguous, especially if it's something
Yep.
like more like object-oriented design problems. I don't know if you've encountered
Yep.
those, but it might. I guess Amazon might do that too. But it'll be something like uh, one of the questions I got was like design a parking system, and so the first step they'll give you well like the requirements of a parking spot, and then the second question I got was like design a parking lot, but then figuring out well what are the ways that someone wants me to implement or utilize a parking spot for the parking lot, like parsing those kind of requirements quickly. Is there any tricks you have for gathering requirements?
Yep. Right. 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 So yeah, like as you mentioned, when someone gives you an ambiguous problem, they are mainly looking at your critical thinking skills and your ability to ask good questions, clarify the requirements, right? So I mean, the key is just to ask questions, right? And I think you have this good instinct where, when I gave you like this graph clone problem, I think not with the first problem as much because, you just jumped into like, I'll do DFS and I'll just solve everything on the fly. But later you realize that you need a map while you're in the middle of the implementation, right?
Right,
So, um, but then in the second one, you were a bit more careful and you were like, there's some catch. It can't be this easy, right? And, that instinct is right. The interviewer won't ask you like a very trivial question. There'll be some complexity there. And when they ask you an ambiguous thing, they're looking for you to ask the questions to unravel the complexity, right? So if it seems too simple, you're probably missing something. So like try to find that, which would be like, okay, just try and implement it in your head a bit and see where you get stuck, right? Maybe that's one tip you could use, like try to find where the ambiguity or the complexity is in the problem, right?
mm-hmm.
So with the parking lot, usually, it's just a 2D grid at the end of the day, right?
Yes,
But so the complexity lies in how do you actually store it in memory. And a simple thing like storing a 2D array in memory is not that easy depending on the context, right? So if it's like you already know the size of the number of spots and everything, you can just reallocate the memory. But if it needs to represent many different kinds of parking lots, the memory sizes could be very different. Um, then you can't just allocate like a bunch of memory, right, for the array.
yeah,
A lot of these things are, sometimes hidden from programmers by language abstractions, but the problem still exists, right? So you can't get away with using a language abstraction when interviewer wants you to explore that complexity, right? Which is, for example, with the second question here, right? You could say that in terms of time complexity, the hash map approach and the list of tuples approach with two pointers is equivalent, right? It's same time complexity, same space complexity.
correct.
But the difference is like if you are with the second approach, you avoid a lot of complexity around memory management, which is abstracted away from you. But when you actually go ahead and implement it at large scale, you'll hit that problem,
Right.
and that's what they're testing, right? That can you think in that direction,
Yeah, I mean,
right? So
I think
part
for
of
me,
it is
this,
realizing what the interviewer wants from you, and if you don't realize it yourself, like just keep asking more questions and just keep asking for feedback, like, okay, this is what I'm planning. Is this fine? If it's not fine for the interviewer, they'll always give you some hint or some step in the right direction, because the interviewer doesn't want you to read their mind, right? They want you to sort of ask good questions so that they can answer it without revealing the solution. I hope that was helpful for you.
Yeah, I think so.
Great. Yeah. Uh, Anything else you wanna discuss?
No, I think that's all I had.
Yeah, I mean, and the last thing I'll say is that, like, you are well prepared. Do you actually have any interviews lined up already?
Right now, I just have the Quora and the Reddit phone screen, but they're less. I don't know if they're leak code even or not, like these type of problems or not.
Yeah. So you have phone screens. You have no on-site interviews booked yet, right?
No, no on sites yet.
Yeah. So, it's a tough market. Keep your head up. Just because you're getting rejected in this market sometimes doesn't mean that, there's some problem with you, right? Uh, so yeah, just keep trying. It's a tough market. Um, you've prepared pretty well. I don't think lead code is going to be a reason for you to get rejected. But at the same time, it depends on the day and the performance on the day and the pressure, right? So just have some confidence. You've done well. If you got a meta on site, you would pass it. So yeah, and part of it is luck. You can't do anything much about that. But if you get a chance for now on site, you'll definitely do well.
Glad to hear it.
All right. Yeah, it was great talking to you, and I'll send you the written feedback soon.
Yeah, thanks
Thanks.
so much.